Here we have a problem on quadratic equation. Okay, let's go to the question. The sides of an equilateral triangle are shortened by 12 units, 13 units and 14 units respectively, and a right triangle is formed. Find the length of the side of equilateral triangle. Okay, first let me draw an equilateral triangle and also a right triangle. Here I have drawn an equilateral triangle and also a right triangle. This is equilateral triangle and this is a right triangle. Since this is an equilateral triangle, all the three sides must be equal. Let me assume x as the length of each side of this equilateral triangle. So now our aim is to find the value of x, which represents the length of the side of equilateral triangle. Okay, now we are going to shorten, that is decrease the sides of an equilateral triangle by 12 units, 13 units and 14 units. Okay, let me take the first side of the equilateral triangle x. This x has to be shortened by 12 units, then the new length will be x negative 12. And let me take the second side x. So it has to be shortened by 13, then this is a second length. And now the third side of the equilateral triangle has to be shortened by 14, that is x negative 14. Since I have shortened the three sides of the equilateral triangle by 12, 13 and 14, so these are the new lengths I am getting. According to the question, these three new lengths form a right angle triangle. So if these are the lengths of a right angle triangle, which one can be the hypotenuse? In a right triangle, we know that the hypotenuse is the longest side. So in these three lengths, we have to find the one which is greatest in value. So here in the first one, we have subtracted 12 from x. In the second one, we have subtracted 13 from x. The third one, we have subtracted from 14 from x. So in this one, we have subtracted the smallest value 12, that is from x. So this must be the, this must be having the greatest in value among all these three. So x negative 12, this length must represent the hypotenuse of the triangle, because in this only we have subtracted the smallest value from x. So this x negative 12 is the hypotenuse of the triangle, and these two are the remaining two legs, x negative 13, and here we can take x negative 14. Okay, since this x negative 12, x negative 14, x negative 3 are the sides of the right triangle, we can use Pythagorean theorem. So Pythagorean theorem says the sum of the squares of two legs always equals to the square of the hypotenuse. Then I am getting x negative 13 the whole square positive x negative 14 the whole square equals to x negative 12 the whole square. So in this equation, I have to solve for x, which represents the length of the equilateral triangle. Okay, now to get the expansion of the square of a binomial over here, we can use the algebraic identity, that is a negative b the whole square, which is equal to a square negative 2ab positive b square. So this is an identity in algebra. So to get the expansion of the square of a binomial in this form, that is we have a negative sign between the two terms a and b. Okay, now we just have to compare the square of a binomial over here, all of them with this one. Okay, so when I compare this one with this, I am getting x at the place of a and 13 at the place of b. So to get the expansion of this one, I have to use a trinomial over here. At the place of a, I have to write x, and at the place of b, I have to write 13. The same thing I have to do with this one and this one as well. Okay, let me do it. We get x square negative 2 times x times 13 positive 13 square. Let me expand this one. That is x square negative 2ab. For a we have x, for b we have 14, and positive b square, that is 14 square. The same thing we have to do on the right side as well. That is x square negative 2 times x times 12 positive 12 square. Okay, now let me do some simplification. We get x square. When I multiply this 2x and 13, I'm getting 26x. Here we have negative, that is a negative 26x. And the value of this 13 square is 169 positive x square, negative 28x positive 196, and here x square negative 24x positive 144. Okay, now let's combine the like terms over here. When I combine this x square and x square, I'm getting 2x square. And when I combine this negative 26x and negative 28x, I'm getting negative 54x. And when I combine this positive 169 and this positive 196, I am getting positive 365 equals to x square negative 24x positive 144. Okay, here almost we have a quadratic equation in the variable x, but it's not in standard form. Standard form means it has to be in the form of ax square positive bx positive c equals to 0. That is, we'll have everything on one side of the equation, and the other side we must have 0. Okay, now let's try to make the right side of this equation as 0. For that, we have to get rid of all these three terms on the right side. For that, let me subtract x square from both sides, and also let me add 24x to both sides. Let me do it, and also let me subtract 144 from both sides. This positive 144, negative 144 will cancel out, and this one will cancel, this one will cancel out. So here when I combine these two x square and negative x square, I'm just getting x square. When I combine these two terms, I'm getting negative 30x. When I combine positive 365 and 144, I'm getting positive 221. On the right side, everything cancels out. We just get 0. Now we got this quadratic equation in standard form. Okay, we can try to solve this quadratic equation by factoring. For that, we have to multiply this constant term positive 221 by the coefficient of x square. In this case, it's 1. When I multiply this positive 221 by the coefficient of x square 1, I'm still getting positive 221. Okay, now what I have to do is I have to get two factors over here so that the product of these two factors equals to positive 221, and the sum of these two factors must be equal to the coefficient of x, that is negative 30. I think negative 13 and negative 17 will work. When I multiply negative 13 and negative 17, I am getting a positive 221, and also when I add them, I am getting negative 30, which is coefficient of x over here. Okay, further I have to divide these two factors by the coefficient of x square over here, that is 1. Even if I divide them by 1, still I'm getting negative 13 and negative 17. Usually when I solve a quadratic equation, I'll be getting two values for x. Now to get the first value of x, I have to change the sign of the first factor over here. So already it's negative. If I change the sign, it will be positive, that is x equals to positive 13. And to get the second value of x, I have to change the sign of the second factor over here. So already it's negative. If I change the sign, it will be positive. So I'm getting two values for x. One is x equals to 13 and other one is x equals to 17. Actually, x represents the length of the side of the equilateral triangle. So since both of them are positive values, which one can be considered as the length of the side of equilateral triangle? So for that, we have to verify both the answers. Okay, let me erase all the stuff and continue the problem. X equals to 13 and 17. Okay, now let's verify the first value of x. That is 13. Let me write 13 3 times because for a triangle we have 3 sides. Okay, according to the instruction, we have to shorten the size of the equilateral triangle by 12, 13 and 14 units. Let me do this. Let me subtract 12 from the first side of the equilateral triangle. Let me subtract 13 from the second side of the equilateral triangle and 14 from the third side of the equilateral triangle. So 13 negative 12 is just 1 and 13 negative 13 is 0 and 13 negative 14 is negative 1. Actually, when I shorten the sides of an equilateral triangle by 12, 13 and 14 units, a right triangle is formed. That's the information given in the question. So these are the sides of a right triangle, but it's not possible because 0 cannot be the length of any side of a triangle, and also negative value can never be the length. So the value we get for x13 does not meet the condition given over here. So we can reject the first value of x, that is 13. Let me consider the second value of x, that is 17. Let me write 17 3 times, and now these are the three sides of, these are the sides of the equilateral triangle. Now let me shorten the three sides of the equilateral triangle by 12, 13 and 14. Let me do it. 12, negative 12 and negative 13 and here negative 14. So here the answer for this one is 5 and the answer for this one is, that is 17 negative 13 is just 4 and 17 negative 14 is 3. Okay, here we are getting, when I shorten the size of the equilateral triangle, I'm getting 5, 4, 3. And so clearly this 3, 4, 5 are the sides of a right angle triangle. So when the length of the side of the equilateral triangle is 17 units. So and also when I shorten this length by 12 units, 13 units, 14 units. So I am getting the sides of a right triangle. That is a right triangle is formed. Therefore, the length of the side of equilateral triangle is 17 units.